In this lecture, we'll talk about the Cartesian coordinates and how do we utilize the unit vectors and building vectors and Cartesian coordinates. So let's have the coordinates as y, x, and z. Then those axes, x, y, and z, are perpendicular on each other, and there is a unit vector associated with them, such that everyone has its own unit vector that is unity and pointing in the positive direction of this axis. So if I am to write the unit vectors for those axes, then I will have this one as I hat, that is unity and pointing in the positive direction of x, and then j hat, also unity has a magnitude of 1 and points in the positive direction of y, and then the k hat that has also a magnitude of 1 and points in the positive direction of z. So if I'm now to divide put the scale 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So if I have a point that I would like to define in this coordinate, this point has its coordinates as x, y, and z in this order, then if I assume that this A has 2, 3, and 3, this means that x would be 2, y is 3, and z is 3. So in order for me to locate this point, I need to draw dash line that is parallel to x, and here another one that is parallel to y. The intercept point defines the location on the xy plane, and then from that point I go up perpendicular on that plane to reach 4. So this is going to be, if I'm to draw a dash line here, now in order to define the accurate location of that point, I need to go parallel from the point of z here. If you go parallel to x, and then parallel to y till you intercept with the line you drawn, this one would be the location of A. So this is the location of the point A in the Cartesian coordinates. This point can define a vector where that vector is between the point A and the origin of coordinates. So if I am to draw this vector, then this vector would be between A and the origin. Now this vector A can be written in terms of those coordinates that have those coordinates on the x, y, and z in terms of the unit vectors that that those axes have. For example, I can say now this vector is the summation of 2, the vector on the x-axis, which is 2I hat, plus the vector on the y, which is 3j hat, plus the vector on the z, which is 3k hat as well. So this is the vector A that is defined by the point A between the point A and the origin of the coordinates. Now, if I want to talk a bit about those unit vectors and what is the relationship between those unit vectors when it comes to the dot product and the cross product, then I can say that this unit vector I hat, if I take the dot product between this unit vector I hat and any other vectors, j hat, for example, the result is going to be a scalar. Why? Because the dot product is the magnitude of the first one times the magnitude of the second one times cosine theta. Now, cosine theta between I hat and j hat, as we said, is 90 degrees. So I have this one as 90 degrees. This means the dot product between the unit vectors that are perpendicular on each other equals to 0 because cosine 90 degrees is 0, which means that I hat dot j hat is 0. And this is going to be the same for the other two combinations, which means that I hat dot j hat equals to I hat dot k hat equals to j hat dot k hat and all equals to 0. However, if you take the dot product between any unit vector and itself is going to be 1. So I hat dot I hat equals to I hat magnitude times I hat magnitude times cosine 0. And this is going to be 1, which means I hat dot I hat equals to j hat dot j hat equals to k hat dot k hat equals to 1. So this is the dot product between uh, any two unit vectors and the Cartesian coordinates, because we know that the definition of the dot product of two vectors is the magnitude of the first times the magnitude of the second times the cosine of the angle between them. Now, if we go to the cross product, then we know that I hat plus j hat equals to k hat. Where did you get this one from? Well, we know that the cross product for any vectors equals to the magnitude of the first one times the magnitude of the second one times sine the angle in between, and then the direction is defined by the right hand rule. So if we say in this case that the angle between I and J is 90 degrees, then this one becomes 1, and this one is 1 also, and this one is 1. So we need to find the direction of the I cross J. If we look at the right-hand rule, for any two vectors in general, we will see that the direction is always perpendicular, such that the index is pointing toward the first vector, and the middle finger is pointing toward the second vector. Then the thumb will be pointing toward the resulting vector. So if I am to align this unit vector, this right hand on the x on my Cartesian coordinates, in this case, I will align it. The Cartesian coordinates is going to look like this is x, and this is y. In this case, this one would be z. So if my vector A is pointing in the x, and my vector B is pointing in the y-axis, the resulting vector will be pointing along the z-axis. So this is going to be, for example, here, the magnitude and k hat for this case. So if I go back now to my original page, then I have here k hat. So if I am to come up now with the diagram that helps me in finding the cross product between the unit vectors and Cartesian coordinates, then I can draw this such that the rotation clockwise is the positive, which means if I am to go I cross J, I would be get K. If I am to go J cross K, then I will be getting I hat, then K hat cross J hat equals to I hat equals to J hat. Now, if I am to go counterclockwise, in this case, whatever cross product I do, I should be getting a negative result. So let's see, if I go J cross I, J hat cross I hat, then since I'm going in the opposite direction, the answer should be minus K hat. If I go I hat cross K hat, the answer would be minus J hat. If I am to go J hat or K hat cross J hat, the answer would be minus I hat.